Imuno-Vaccine Advances by Dr. Kiran at the ISPNO Family Day panel discussion, July 2008.
Imuno-Vaccines is just one of a large array of novel, experimental therapies where we are asking questions. Will this approach lead to cures in places where we haven't been effective previously? There are novel drugs, anti-angiogenic or anti-blood vessel compounds, there are novel chemotherapeutics, there are novel ways of giving drugs. And so in the larger class of all of these experimental approaches is immunotherapy. And something that neuropathologists have been telling us for many, many decades is it's striking how many tumors have this massive amount of infiltrate, like your immune system is trying to react against the tumor but can't seem to knock it off. And there are many infections that do the same thing. They actually generate an immune response, but they force the body to generate the wrong immune response so that it can't effectively get rid of the tumor. Obviously, in the cases where the immune system is successful, you never presumably know you had a tumor because you got rid of it, in the same way that you don't always know that you got an infection if your immune system can clear it quickly. That's the whole concept of immunization. But similarly, there are other brain tumors where you see no inflammatory or no immune response whatsoever. It's as if your immune system is totally unaware of what's going on. And obviously that's a different approach tumors have taken. And so there is this huge field of immunotherapy where people are beginning to ask, is there a way to either awaken your immune system or redirect your immune system, given how many billions of years that's had to evolve to pick up abnormal cells, abnormal proteins, and see whether you can harness that energy to get rid of the tumors. And this is a very early field, so the answer is not yes or no. It is, we're still figuring out how to turn on the immune system, how to effectively deliver that immune system into the brain so that it can do what it needs to do without damaging the normal brain. Because as with every experimental therapy, there are risks and benefits. The benefit is we may be able to make this effective. The risk is you have to make sure you don't accidentally damage the normal brain. And for those of you that, without wanting to scare people, there are things like, multiple sclerosis is probably an immune disease of the central nervous system that causes obviously a lot of damage. So activating the immune system isn't always a good thing in the brain. It's got to be done in a controlled and intelligent fashion. And those are the clinical trials that are going on right now. The three major ways that they work is you can either inject a new immune molecule into the brain to actually kind of generate the response, and there are many places doing that. There are some clinical trials where they take some of your tumor out, they put some immune system of your immune system into a dish, they kind of put the two together to get to know each other for a while, teach the immune system what it should be looking for, and then inject those back into your body as a way of hopefully educating it. And then there are ways that work in combination with chemotherapy and radiation to try and induce an immune response from scratch. It's not that one is better than the other, they're all being studied. So far, although there are early promising results in adults with glioblastoma, a highly malignant tumor in adults, we are just really starting these studies in pediatrics, so it's too early to say what the answer is going to be, but I think it's an area that holds an enormous amount of promise. It's just not quite ready for prime time, and you would have to really be part of a protocol to be involved in that kind of study.